All right. So this is about zero trust. It is about sovereignty. It is about being able to guarantee that what's running on your cluster is what you want it to do, that you're able to separate different domains. So if you have cluster A and cluster B, you're able to separate those. You're able to do that dynamically so that you can open it up or close it. All right. So this is our current area. This is where we are today, right? This is the status quo, as it were. And there's a problem with it. And that is you suddenly have regions. And those regions can be things like different locality. Let's say you have one of your clusters in France and they need to be isolated. Or you have high security areas that you need to separate. So multi-region could be a different thing. But trust leakage is an issue if you don't apply zero trust. Supply chain compromise. I think everyone in the room probably knows about Vercel and what happened there. Hacker News is a good article and some analysis. And I think Lovable just came out and said, yeah, we've also got the same thing. And part of that was a supply chain compromise. So there's that. The AI artifacts, these runtimes are still maturing. People are still figuring out how they do it. You will find that a lot of enterprises, organizations are running models that they can't actually determine have the right type of provenance that they need to have. And then this lateral movement. I think this is probably one of the biggest issues that people today currently face. When you build your cloud native environment, your path of least resistance is just to continue to deploy outwards, right? Cluster A, B, C, D, E, F, G, right? All directly down from a higher cluster management place. So what do we do? Single source of truth for everything. I will share out all of these slides. There's a lot in the diagram. I'm also going to post a blog post. I'll also have GitHub out there so you can go and pull all this here. But essentially, the foundational model is that you need to start looking at things like OCI if you're not already. OCI is not just for your delivery of your Helm charts or your images. It starts covering things like your metadata, your AI models, artifacts that you're going to be doing in it. This is opinionated. Understand that it's the concept of the architecture here. Like, for example, I might use Harbor for what I'm doing. You need a compliant OCI registry to be able to do it. I recommend Harbor because our product's based on it, but it doesn't need to be. So if you look further down, we have this pull verify trust here. How many of you are familiar with SPIRE and SPIFFE? Yeah, very few in the room probably are aware of it. Right now today, the traditional thing is you use OpenBow or Vault, and you use Cert Manager. Agentic AI is really forcing this third part of the certificate management, and that is around SPIFFE. I'll talk about it more in depth. Kyverno, also foundational here. If you don't like Kyverno and you're an OPA shop or something, you can switch it out as well. We use Kyverno because it's closer to Kubernetes. Cordon is our Kubernetes platform. Take your choice of whatever platform that is that you use. I would recommend K0s, especially as I'm in the Nordics, and K0s was born in Finland. So, a little bit of support there. We also donated K0s to the CNCF Foundation, so it is a CNCF project. Runtimes, obviously, observability. And then we can go up into the workloads in a second here. All right. So the concept here is that instead of having that scale out across a very flat environment. How do you actually start enforcing trust, zero trust inside of your environment is a sharded trust model, right? Sharding is an overused term, it's generic, but I think everyone understands what it is. That you shard your areas of trust so that you have one trust domain that is allowed to run secure, one that's allowed to run insecure, whatever those definitions are. The idea is we have the concept of, in here it still says mothership, but it's a multi-cluster management cluster overhead. So you have your top, and then it breaks down to regional trust domains. So those are additional clusters that fall under it that are management clusters. And then below that, you run your worker clusters or child clusters, right? So each of these regions, you have your own trust boundaries established. They're independent, but you still have oversight from above. And federation is explicit. You have to enable it. Not it's a opt-in versus an opt-out. So that's a model. So here's a picture. There we go. All right. So this is what we envision, what we have running, what we've built, what we've tested that works well. So sharding it creates that isolation. It's not for scaling. Yes, it also can allow you to scale, but the intent is building sharded trust domains that you would use. So you can see at the very top what I talked about with MCM. That's your multi-cluster management layer, and then you break down into, it has global visibility. It can see everything, unless you turn a trust domain off to not allow that, which is possible, right? It owns the contracts for the policy management you define at that level. So your platform engineering team, if you envision it that way, that's where all of the policy is defined. That goes down. And the federation control, like who, if trust domain A can talk to trust domain B, who inside of each one of those. That's that layer. And then if you see, I've got regions that are broken down. So region A, B, and C, they're all the same if you can see that. But again, it's where your SPIRE services are running. It's where your Kyverno services are running, your OCI control plane, and that regional cluster. It gets its contracts, its orders, its configurations from the MCM, but it can also then override it, right? And say, we will not accept that contract. This is how we start enforcing that control. And then, that boundary then starts doing things like you have dedicated CAs in there. So this is where your open bow, your SPIRE starts to kick in. And then it starts to manage that. So the key takeaway is once you establish these trusted domains, this is not for scaling, but you trusted domains of this, you can then start adjusting your requirements of where and what and who can actually do what they're allowed to do or not. All right, so architecture layer, very, very standard. Trust, identity, and MTLS. The OCI control plane, policy enforcement execution, and coordinate exposes the contract. As a recap. All right, so according to sharded architecture, here again, we're sort of breaking out what this looks like. And essentially, the only thing that I want you to really see here is now we've gone into what the regions look like, is that federation channel. Everything communicates through encryption there. Then if you look at the region A, you can see the components. And I need to sort of touch in on this. So you see you'll have an HSM and you'll have TPM. In my GitHub and blog posts, I've got detailed configurations of how to do this. But this is core critical for everything you do. Now, the multi-cluster management will have, again, also intermediate CA that it has, its own, that then generates the CAs for going downstream. So your certificates are multi-layered and they inherit from above. It is HSM based in what we're doing. So that means you will have an offline HSM that generates it, and all of these will have attestation that you're able to verify against, right? Automatically, obviously. But it means that, so HSM, that root of trust, flows down, it never flows up. It means you can then revoke if you feel that one of your clusters has been compromised or for those other reasons. TPM, I think TPM out of all, TPM, how many of you use TPM in your deployments? A couple, right? How many actually then make sure that a node can only deploy if the TPM audit comes back as positive? Not many, right? We kind of use TPM almost as a dashboard, a dial, but we're not actually using it for what it's required to do. And in Kubernetes, that means that unless the TPM says, yes, this is valid, and there's a label there, the admission controller will not let you deploy either the cluster, those nodes, and then further down, what workloads then match those TPM signatures so that you can actually deploy the workloads on there, right? So you have that control. Having that type of architecture where you have both TPM, which is allowing the state of your platforms, and an authoritative CA system in place means that it's very, very difficult for you to start being able to deploy your workloads into areas that you can or cannot do. So on the GitHub, I have little workbooks that you can go through too if you want to, run books, and you can set this up and do it. Again, that federation control plane down at the bottom that's managed by the multi-cluster manager is responsible to distribute the policy, which we use with Kyverno. The trust bundle exchange. So your trust bundle are a collection of certificates. So for example, you would need the certificate from the MCM. You'd need the certificate that's generated from your region A. This is how you can encrypt your MTLS and make sure that no one else can get to it. And along with your OCI registry, which will also have its own unique certificate. So when you start thinking about the concept of a trust bundle, don't think about, I just need one cert that's going to work. You have a trust bundle. So it's always going to be at least 3 when you're able to do this. And this means that when you have compromise, you're able to then revoke the correct certs that are there. Observability and aggregation within Cordant, we use Victoria metrics. You can use Prometheus. You can use a lot of different things. But then you architect violations easily. And this is all managed, again, through the multi-cluster top layer. And I'll talk about what Cordant does. The way that we distribute everything is immutable. So even if you have a region that changes one of the policies, it gets reverted back, right? So these things are immutable. And the compliance reporting, right, which ties into observability, and you define that yourself. So Trust Foundation, just sort of reinforcing again, offline root with the CA, so it's HSM backed. There's a lot of ways that you can do an HSM. Make sure that when you're working with your organization, the understanding of FIPS compliance for the HSM, if you need it or if you don't, right? You can just sign off. I think what is the German HSM? I think you can get it for 99 euros. It's nothing. Won't pass the FIPS requirement, but it is solid and open source. And then you can get all the way up to where you get EU providers, as an example, who provide the HSM service to you so that you don't even have to worry about it. Then you're talking 50K a year type of thing. So you've got that broad HSM. And certainly, when you're testing, you don't even need an HSM itself. Intermediate CAs, foundational, issued per management and regional domain. So that type of automation happens. So to, again, reinforce the way that you're splitting everything apart. TPM measured boot provides the node evidence. I have recommendations in the runbook for you to start at a certain layer of what you're doing with TPM. So you would start with 2 or 3, and then you're going to dial it in more and more so that you're passing, I think there's 8 stanzas for TPM, by and large, something like that. But you would go through and you would expand it, right? If you do it right away, what's going to happen is you're just going to have a lot of problems. You're not going to know why. At least that's what I learned. And then, you need the attestation that's there. Attestation, all of these tools that I'm talking about here are all open source, by the way. So it's there. How many of you are running attestations? Few, none, some. Relatively trivial to implement. Again, you can start with free and open source. That's all you need. The challenge is if you're using you're trying to use the TPM chips that are, you need to set up essentially a TPM node, right? And when you do that with the TPM node, it means suddenly if you're using the TPM that's in the TPM node, then you can't use that as the broker for the TPM broker that you can then validate against. So, entry level TPM device, I think, is maybe 50 euros. And then the price goes up to whatever you want, the organization does. All right, so let's move on because I know we don't have a lot of time. I'm really trying to cruise through this as fast as I can. So end-to-end zero trust flow. If you look at this here, we've got the trust establishment that we're doing. We're establishing it with HSM and TPM. Then we're going through with the runtime verification. And I'll talk a little bit about these two as time permits. And then down to the enforcement of what you do. So you can look at that as 3 different levels. How are we doing on time? Are we okay? I don't know. He's on the phone. Sorry. Don't worry about it.
It's 10 minutes left.
10 minutes. All right, I'm going to start cruising through these, and I'll make sure that you guys get all of this. All right, so logical breakdown of how we do it. So policy is the gate. Very much, I will be sharing Kyverno policy with everybody. But what you're going to essentially do, this is a workflow here. You request, the user submits the request. It goes to the Kubernetes API server. We choose Kyverno because of the tight integration Kyverno has with Kubernetes. That's why we are choosing it, because we know how we can instrument and really carefully watch what we're doing inside of Kubernetes and Kyverno, that they're aligned and matched. It goes through and does the verification checks. You can see that it's quite extensive in what it's doing. And then it's either allow or deny, right? And then this will provide you with a way for you to trace when something's denied or allowed, right? Through this area. I will share out examples of the policy sources that I do. Something that I think is good is to call out are the labels and standards. The labels is you will get a lot of that from the TPM and the HSM. Automatically label those, right? So that you're able to have that defined way of doing it. All right, let me talk a little bit about SPIRE and SPIFFE. If you haven't heard about it, And most people had never heard about it until KubeCon a month and a half ago. It is the new. So traditionally, you have a way for you to generate your certificates, right? You can either use command line, OpenSSL to be able to generate that intermediate that you get from the CA, or if you're starting from scratch, you generate CA that way. And that's good. And you still need to apply it and use it. It's foundational to what we're doing here by generating certificates. The challenge that has really come in, and the reason for SPIRE and SPIFFE, is that if you start thinking about agentic workloads, right, where you have agents that are going to spin up, do some work, and then spin down again, and then another one will spin up and spin down again. Each one of those, how do you authenticate it? Right? How do you actually authenticate that agent, create that certificate dynamically, right? So what SPIRE is really all about is being able to make sure that you have these very short-lived runtime identity. That's what you're doing, right? Agentic agents is an example. There are a lot of other examples of why you'd want to do this. You will find that, if you work with organizations like Control Plane, that, they're DevSecOps, right? They wrote the book on security for Kubernetes. They have a lot of exploits because certs are not short-lived, right? Because with certs, you're going to create those certificates. We treat them like gold for some reason. I don't know why, but we do, right? I know I used to. And then we rely on Cert Manager to be the gopher to run around and hand them out. That's not fast enough. And so that's why SPIFFE and SPIRE exist today. And you'll start to learn, you will start hearing a lot more people talking about this than you have in the past. Solves a real problem, quite a new project. It will start to grow. It will never replace OpenBow or anything like that. All right, I'll just go to here. According Zero Trust architecture. This is sort of just a recap of what we covered here, but on a very broad sense, and I'm going to tie in sovereignty into this. If you implement this workflow and you have established runtimes, runbooks, and you have clear ways to be able to observe what it is that you've built your observability to be able to capture those logs where it's failed, applied, denied. If you do it well, it will be the path of least resistance for your teams to use. If you do not do it well, they're going to try and work around this and avoid it as much as possible. So the rollout of doing Zero Trust is far more critical if you want success on a day-to-day operation. And when we talk about sovereignty, I'm from the UK. For us, sovereignty, and I'm pretty sure everyone else in the room here, because we're mostly from the EU, Europe, Scandinavian regions, is one of the most important things. The regional trust domains is how you define sovereignty if you have to have it within your cloud-native fleet, right? Applying these rules already sets you up for a sovereign cloud on its own. But by using these regions of trust domains, you can actually create independent sovereign areas even within your own organization, so that you can have, we have a customer in France who requires this. They're in France and they're in the UK, and they have to have the French area sovereign. And so we can prove it. It works. Both the French government says, yes, this is sovereign, and we can do that. I'd like to know if there's any questions around this. If not, thank you for being my test of what we're enforcing here with Cordon Zero Trust. But I think made a lot of effort to not have any proprietary or any, you need a license or anything to be able to do this. And with the way we've built it, you don't need that. I would also, just last thing is, Cordant, if you want to try it out, I didn't have the opportunity to really dive in on what Cordant does. It is open source. It's on GitHub. Search for Cordant, you'll find it. You can download it, you can run it, and go from there.